This is section 2.5a, which is like part 2 of section 2.5. Section 2.5 talked about inequalities, and this one is just like combining absolute values and inequalities together. So we're talking about both of them at the same time. The first two things that are introduced in this section, let me make this bigger. Are you guys whispering, saying make that bigger? If I don't, make sure you remember to tell me to make it bigger. Okay, because I do that a lot. Whatever. Intersection method and x-intercept method. Okay, we talked about those before, but it did not have to do with inequalities. I wrote this on the board like a while back. The intersection method and the x-intercept method. I think I had them in the reverse order on the board earlier. Whatever. When you're doing the x-intercept method and you're graphing them on Desmos, you have like stuff on both sides of now an inequality symbol, whatever that inequality symbol is, and you want to get everything to one side. So get stuff on one side and 0 on the other. You get the stuff on the one side and the 0 on the other, and then you graph on Desmos or whatever, your graphing calculator, and then you look for the x-intercepts. Okay, that's how you solve the x-intercept method. In the intersection method, like if you have something like this going on, you're going to let this one be your first equation. You're going to have two equations. I'll put two inequalities because they're not equations, they're inequalities. So you have a y1 and a y2, and then you look to see where they intersect. And that is the solution, okay? Your graphs, if you do one versus the other, are going to look very different, but you're going to get the same answer if you do it whichever method you use. You're going to get the same answer. The graphs will look different because on one side you're going to have two graphs. On the other side you're only going to have one graph. The graphs will look different, but you will get the same answer regardless of which method you use. Okay. A lot of times if you have an absolute value on one side, like this first example, you cannot move this 11x to the other side because you can't shove him inside of the absolute value. So in this one, you only have one option. You can only use the intersection method. Does that make sense? Okay, so we're going to do this one here. And I've given the graph over here, but I'm going to also go ahead and graph this on Desmos so we can see this a little easier because I can't do the points very well. Okay, I'm going to zoom in. There's my equation. On Desmos, we've got a y1 and a y2. So y1. And I'm just going to, when you write this in here, you're going to put an equal sign. I'm going to do y1 equals the absolute value stuff, and I'm going to do y2 equals 11x. Okay, that's the way I set this up. We'll worry about the inequality here in just a second. So to figure out how to do inequality or their absolute value, there's a key on your keyboard, or you can go down here to the bottom corner. And there's like a little absolute value of a. That's how you pull those up. So this bottom corner down here will get those inequalities for you, or absolute values for you. X to the fourth plus 2x squared minus x plus 2. And I'm going to close my absolute value. So there's that one. Kind of looks like a parabola, a little bit loopy maybe of a parabola. That's what he looks like. Okay. And the other one I'm going to do y2. y2 equals 11x. Okay. Woo. There's this guy. There's that. All right. So there's kind of two places where they intersect each other. Okay, we're looking for the intersection method. Two places where they intersect each other. And those two places are at, let me zoom in here. Those two places are at this dot. We're only looking at the x coordinates. I'm going to write these over here. At 0.1716. We'll worry about the inequality part of that here in just a second. And the other one where they intersect each other is all the way up here. Come on. Come on. Come on. This one right here. 1.9232. 1.9232. Okay, now we have to decide what our solution looks like, okay? So we want to know when, if we look at the original example, when the absolute value part of it is less than this equation, okay? So our equation for 11x was the blue line. I want to know when my absolute value part, the red line, is below the blue line, right? That's what that means. When the red part of it is below or less than the blue part. Does that make sense? It's going to be x values that are between the 0.176 and 1.923. Those places in between there is where the red line is lower than the blue line. Otherwise, the red line is above the blue line. Does that make sense to you? Yes? Shake your head, yes. So what this will look like is we write 0.1716 is going to be less than x. X is like trapped in between those two values. Okay, because that's where my red line is below my blue line. Yeah. Now, is it less than or equal to or just less than? Like, do these symbols right here have equal to parts of it or not? How do you know? You look at the original equation. The original equation does not have equal to symbols, so no, we don't have that. Okay? This is my solution. That's the intersection method. Okay? Now, this other one, x-intercept method, I kind of like this one better, except there's one thing that you have to do to set this guy up. If I want to do the x-intercept method, I have to do something first. What do you have to do first? X-intercept method, I have to get 0 on one side, right? So I bumped the 3, yep. Subtract 3 and move it over here. So when I type this in, it's going to look like this. Again, the 3 stays on the outside of the absolute value. Okay, he can't go on the inside. So we're going to do that, and we're going to type that one in. Yes? You can. Yes. You have to hit the math button. Okay? And do you have to go over? Math button. Hit the math button. Show over. Math button. It's ABS. Go over. ABS is the first one. Yeah. So math, go over ABS. It should be there. Yeah. And it will bring up nice, pretty absolute value bars for you. Okay? Perfect. Just set it there. Okay. So this one, I'm going to do y equals absolute value, and I'm going to have some really ugly stuff. I do parentheses x plus 4 divided by parentheses x minus 2. And it looks like that. Close my absolute value, and then minus 3. Like that. Okay? This is what I have going on here. This is the graph of him. Okay? So I'm looking at the x-intercept. I want to know where this graph is greater than 0. 0 is like basically where the x-axis lives, so I want to know where he is above the x-axis. He's above the x-axis between the two values. Does that make sense? In between these two places, he's above the x-axis. Outside of those two places, he goes below. So my x is going to look like something between whatever those two values are. They're right here and right here also on your graph, because I gave you the graph of that. Those 2 points are located at, what's the x-coordinate there? 0.5. So 0.5 is less than x, which is less than, over here is 5. So in between the values of 0 and 5, my graph is going to be greater than 0. That's what we're looking for, greater than 0. Okay, does that make sense? Is it greater than or equal to or less than or equal to, or just less than? Less than, because this thing doesn't have an equal to symbol. Okay, now there's one more trick to this. There's a problem here. If you look at this graph, he has a vertical asymptote. If you keep looking at this graph, I'm going to zoom out, 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 out. Those lines are going straight up, and they are never crossing that asymptote there. You know where that asymptote is located? Did you just answer my question, Colby? You should know where that asymptote is located. The limit does not exist at where? Look at the equation. 2. Okay, if you look at our domain error, we can't divide by 0, right? If x is 2, we have a problem. That's what it looks like on the graph, okay? We have a vertical asymptote at 2 because our graph never touches the value of 2. So how do I incorporate that into this thing? I'm going to cheat. I'm going to say this is my solution region, but x can't be 2 also. What? No, bracket is a closed dot. So x can't be 2 also. If you want to write this in like technical terms, we have 0.5 is less than x, which is less than 2, and then 2 is less than x, which is less than 5. Or you could do 0.5, comma 2 with brackets unioned with 2, comma 5. So there are 3 ways. This is one way that you could write it. This is a second way you can write it, or you can cheat and do that. Okay. But since we have a domain error there at 2, x can't be 2 because it's never going to touch 2. Does that make sense? Okay. All right. That was the long part. The rest of this is easier. What? Because actually, technically, you could have. Yes. If you wanted to, you could have technically moved that 11x over to the other side. I told you you couldn't. You can't put the 11x inside of the square root. So if you moved it over and made it similar to what it looked like down here, you'd have the absolute value of that junky stuff minus 11x, and you could have set that equal to 0. That would have worked too. So yes, you're right, Katie. You could have done that, but you can't put the 11x inside of the absolute value. So that would have worked. It would have just kind of been ugly to type in, but it's all ugly anyway. So yeah, I'm sorry. The first one, you could have done that too. Yes. Yes. Okay. Thank you. Good. Moving on. This bottom part down here is talking about the algebra of absolute values. I'm going to get rid of Desmos because I don't think we need him anymore. It's talking about like absolute value just means the distance that something is from 0. So if we're talking about 0 and we're doing absolute value of r is less than 5, it's talking about like 5 on either side. Okay, 5 on either side of 0. Okay. Greater than or equal to, less than or equal to look like this. This is going to be less than or equal to. This is going to be greater than or equal to. Whatever. That's not terribly important. The thing that you just need to know is that absolute value just means distance. Distance from something. That's why there's 2 answers. This is one of your answers, and this is another one of your answers. That's why when we do absolute values, we do 2 solutions, okay? So we're going to be doing the same thing on this back side, 2 solutions. These are going to go by really fast, okay? 2 solutions here, but we just have an inequality representing that. So 2 cases. First case, you just drop the absolute values and leave the symbol exactly the same way, all right? The second case, you put a negative in front of that thing, okay? Now, let's solve the first case first. So add the 7. 3x is less than or equal to 18. I'm going to run out of room. X is less than or equal to 6. That's what that one is. Okay? On the right side, when we solved these when it was an equal sign, I told you just bump the negative over to start with, right? Instead of distributing the negative, just bump the negative over to start with. Okay, now, be careful of this when you're dealing with inequalities. I'm going to bump the negative over, like dividing by a -1. But what happens to an inequality when you divide by a -1? You flip the sign. So when you're dealing with an inequality, you have to do one extra thing besides moving that negative over. You have to flip the sign. If that was an equal sign, it would be just equals -11, and we wouldn't have to worry about it. But flip the sign, okay? Then you're still going to add 7. 3x, I write way too big. 3x is greater than or equal to -4, and x is greater than or equal to -4/3, okay? Now, can it be greater than or equal to -4/3 and less than 6 at the same time? Can we write those 2 pieces together? If you can't think of it, go ahead and put it on a number line. -4/3 greater than or equal to is this. 6 less than or equal to is this. Can it be both at the same time? Yes. So we can write those 2 pieces together. I'm going to write it up here. I'm all over the place. -4/3 is less than or equal to x, which is less than or equal to 6. I can write it like that. Okay, I can write it all as one piece. If you don't put them together, I won't count it wrong, but just keep it like, just make sure you realize that that's one region together. This is an and statement. Just like we did before, and statement. Okay? Now this one, solving an absolute value inequality here, we've got two cases. Again, first case, 5x plus 2 is greater than 3. Just drop the absolute values. Over here, negative 5x plus 2 is greater than 3. Okay? Subtract the 2. 5x is greater than 1. X is greater than 1/5. Am I going too fast? A little bit? Okay, I'll slow down. I'll drink some coffee. Okay. In the second one, divide by the negative. 5x plus 2 is less than negative 3 now, because we flipped the sign. Maybe I should put like a little star up here. Flip sign when times or divide by negative 1. Or just a negative in general. Doesn't have to be negative 1. It can be negative 2, whatever you want. Okay? Flip the sign. All right? Now, subtract the 2. 5x is less than negative 5. And divide by 5. X is less than negative 1. Can you be less than negative 1 and greater than 1/5 at the same time? Less than negative 1 is here. Greater than 1/5 is here. No. Those two pieces you have to leave separate. This is like an or statement. Okay? Oh my gosh, we had lots of time.
Never have time.
This is the longest period. I know, it's math. Math is always the longest period of the day. This is actually a shorter assignment. There's not very many problems. 4 through 32 by 4s. 4 through 32 by 4s. Yeah, it's all of the excursion. That's what this is an excursion. Any of the sections that are point A have less problems with them. So that's exciting. Okay. Solving an absolute value inequality. What? No, you can't write those two as one piece because you can't be. What? No. If you're going to write it in the parenthesis thing, you're going to write negative infinity, comma, negative 1, unioned with 1/5, comma, infinity, because they're going opposite directions. So if you want to write it like that, you sure can. Yeah, since they're going opposite directions, you have to write them in two separate pieces. Good question. Solving an absolute value inequality. Do you want to, let's see, how do we want to do this? We can do this with Desmos again. We can do this by factoring. Let's do that maybe. Let's factor so I can show you what factoring looks like. Okay, so there's the graph of it, whatever. We kind of have the answer-ish already. So this guy I'm going to split into two separate pieces just like we did before, case 1 and case 2. And since it's quadratic, it's going to look a little bit longer. So I'm going to give myself lots and lots of room. The first one, you just take off the absolute values. Okay, the second one is going to look like this, which we're going to divide the negative over here in just a second. Let's go ahead and do that before I start. Divide by negative 1. So x squared minus x minus 4 is less than or equal to negative 2 is what he's going to start with, or what he's going to look like to start. Happy with that? Not happy, but you'll deal. Okay. All right. How do you solve 1? What are we going to do to solve number 1? Put it all on the same side. Yep. Subtract 2. Minus 2 minus 2. X squared minus x minus 6 is greater than or equal to 0. Then what can we do? That one breaks down. That one factors really nice. Multiply to get negative 6, but when you add them, give you negative 1. What multiplies to get negative 6, but when you add them, give you negative 1. Negative 3, positive 2. Negative 3, positive 2. Okay, so if we set this equal to 0, x will be equal to 3, and x will be equal to negative 2. Okay? Since we're going to have 4 numbers probably, because the other side's probably going to have 2, I'm going to put these on a number line. And we're going to do our critical numbers. So these are our critical numbers to test our intervals, because when you're solving quadratics, the symbols, the less than, greater than symbols all get like mumble jumbled together. So yeah, we gotta do this. Okay, let's do this other side. We're going to add 2. So x squared minus x minus 2 is less than or equal to 0. What can you do with that? Break it down again. Multiply to get -2, add to get -1. -2 and 1. X minus 2, x plus 1. So here x equals 2 and x equals -1. So here are our other 2 critical numbers. Okay, let's put all 4 of those on a number line. The first one on the left side is -2. Then we've got -1, then we've got 2, then we've got 3. Okay, and we're going to test. We've got like 5 numbers that we have to test. If you have 4 critical numbers, you have 5 like regions basically to test. Okay, so a number to the left of -2 that you want to test. Have we got one?
-4.
-4, -3? -4, sure. Number between -1 and -2. Sorry, -1.5 is all we've got. Between -1 and +2.
0.
Always 0 if you can. Between 2 and 3. 2.5. Between 3 and infinity. 4. Sure. Okay, we've got all these points to test. All right, I'm going to write this up here. This is my original equation. Is greater than or equal to 2. Okay? This one is not one of those that we can just like, what sign is it? We actually have to compute the x squared minus x minus 4, which isn't too bad. What I'm going to do is I'm going to get my calculator going here. And once you type this in, once, it should be really nice. We're going to use -4 to start with, all right? So parentheses, -4 squared minus parentheses -4 minus 4. Okay, I type that all into this calculator, and I even have a dumb calculator, so I press equals. And I press equals, oh, there we go, 16. So this one came up with the absolute value of 16 is greater than 2. Is that true? Greater than or equal to 2. That is true, so this one works. So we're going to circle him. Okay? Now, I'm going to go in, and I'm going to do 1.5. Actually, let's test 0 first. No, let's do -1.5. Whatever. I'm going to go up, and I'm going to change this 4 to 1. And I've got to insert point, insert 5. Otherwise, it's going to get rid of my stuff that it's going to type over top of what I had before.
Wait, how do you know what type of
Okay, there's an insert button. Yours has it too, right here. You hit second. It's like the delete key. And you insert, and it will give you a new space. Otherwise, it will type over top of what you have already. Yikes. Okay? So, 1, second insert point, second insert 5. And it should have left everything that I wanted. Nope, it didn't do it. Second insert parentheses and square minus 4. Okay? Did you get the insert thing in there? If it doesn't work, just type it again. Whatever. But it makes it really nice if you don't have to. Enter. -4. Absolute value. Is that greater than or equal to 2? Is the absolute value of -4 greater than or equal to 2? Yeah. That one works also. Okay? That one works. Now let's do 0. Actually, let's do 2.5. We've already got a -1.5 in there, so I don't have to change too many things. I'm going to delete the negative and change that 1 to a 2. I'm going to change the 1 to a 2. There we go. Delete the negative, change that 1 to a 2. Enter. -4 is greater than or equal to 2. Does it? Gosh dang it, it does. Poop. What did you get?
0.25.
For this one or for the first one?
For negative 1.5.
Okay, so this one you got what? I'm sorry, I had a square on it. What did you get?
0.25.
0.25? Okay, and this one's 0.25 also? After you take the square, the absolute value? So 0.25 is not greater than 2, so those don't work. Whoop. That one and that one don't work. Yeah? Okay, now let's do 0. Yeah, I took off my square. Okay, so change that to 0, delete, delete. Change this to 0, delete, delete. And that should work. Negative 4 is this one. Is my calculator broken, or is it like coming up negative 4 every time? That's right. Negative 4 is correct for 0? For 0? All right, true, true. Yeah. Okay, now if we plug 4 in, 4, 4, enter, 8. Absolute value of 8 is greater than or equal to 2. That one works. Holy cow. So our number line that we've got going on here is this thing. Nice. Do you want to write this as like the greater than, less than, or you want to write this as like the parentheses? Parentheses? We can write it in both, I guess. Let's do parentheses, and then we'll write it as the other one. I think the parentheses are easier to write. What's this region look like in parentheses? Negative infinity to negative 2. Is it equal to 2 or not equal to 2? Negative 2. It's equal. If you look at our original equation, we have an equal to symbol, so that's going to be a bracket. The next one, this region right here, goes from negative 1 to 2. Parentheses or bracket? Can it be equal to negative 1 or 2? Bracket, bracket. They're both brackets because of this. Okay, and this last one goes from 3 to infinity. Bracket, parentheses. That's what he looks like. Okay? All right. If you don't like to write it like that, if you do like to write it like that, that's it. That's all you have to do. If you don't like to write it like that, this guy will look like x is less than or equal to negative 2. Negative 1 is less than or equal to x is less than or equal to 2. And x is greater than or equal to 3. That's what these guys will look like. So either answer, either way you want to put it, is A-okay with me. Those ones are kind of ugly. And if you don't type it in stupid in your calculator, you'll do much better than I did. Okay? There you go.